Hello everyone, it's Shubhajit here. Welcome to the fifth video of this series wherein I discuss some of the silly mistakes in physics that I committed during my JEE preparation. So you can pause this video and try this question for one time. Then I am proceeding with what mistake I committed. So let me write what is wrong in this. I wrote that we are asked to find the kinetic energy. We are asked to find the length of the thread that unknowns when the kinetic energy becomes equal to K. So if I apply work energy theorem, so kinetic energy I can write as F times D, and so D is what is asked, so D is K divided by F. Work done by normal reaction and mg is 0 and there is no friction, so friction does no work. So our required answer should be K divided by F, but it is wrong. It is not correct. It is not K divided by F. Why? Because see, we are asked the length of the thread that is unknown and we are not asked this D. Let me be more accurate in what I am saying. The work done by a force dW is F dot dx, and dx is the infinitesimal small displacement of the point of application of force. So dx must be the infinitesimal small displacement of the point of application of the force. Let me be more clear. Say if this disk at an instant is rotating, not disk, here it is given cylinder, whatever. So if at an instant it is rotating with omega, so what is the length of the thread that is unknown? Omega r dt, and if we integrate this, then we will get the length of the thread that is unknown. Whereas what is the infinitesimal displacement of this point? See, it is equal to the velocity of this point plus omega r. So if the velocity of the cm is vcm like this, so we can write as vcm plus omega r dt. That will be this. So what we are calling as d is actually this thing, whereas our question wants to ask this thing. So I think you understood what is the difference. So that was the wrong thing in this method. So we are asked integral omega r dt, whereas we are finding integral vcm plus omega r dt. Now let me proceed with what the correct solution must be. So to write the correct solution, see, if this is the cylinder, we are given that the cylinder is a uniform solid cylinder. Okay, as it is a uniform solid cylinder, now see, the force is applied along this line. Consider any point P on this line. Now see, the net torque of all external forces about this point P is 0. Why? Because F is passing through this point. The mg and normal reaction are always equal in magnitude because the cm is not moving in y direction. So always we have n equal to mg. So torque of n and mg cancels about this point, and there is no friction acting. So friction does not provide any torque. So the net torque about this point is 0. So we can conserve angular momentum about this point. So we know that the angular momentum about any point is equal to the angular momentum of the center of mass plus angular momentum about the center of mass, including vector sign, of course. So if the disk is rotating with translating with vcm and rotating with omega, so we can write angular momentum as, it will be conserved, so I can write as r cross mv plus icm into omega. See, icm into omega direction is reversed, so I of this disk about center of mass, because we are finding this is of the center of mass, this component of angular momentum is of the center of mass, and this component is about the center of mass. So I about the center of mass is half mr square, here is I, into omega, and this has to be in negative sign because the direction is opposite, so this must be equal to 0, and when we equate it to 0, we will get that vcm equal to omega r divided by 2, right? So we can write that kinetic energy K is equal to F times integral vcm plus omega r dt. I have just told right now. So what is vcm? Vcm is omega r by 2, so we can write 3 by 2 omega r dt. And what is integral omega r dt? D. So our required answer is D equal to 2k divided by 3f. So this is our required answer. I hope you guys like this video. See you guys in the next video.